Hey everyone, in this video we're going to continue our work with arithmetic sequences. Our first example, given two terms of an arithmetic sequence, determine an explicit formula to find the nth term in the sequence. Assume that n is greater than or equal to 1. So the two terms they've given us are a sub 1 equals 11 and a sub 5 equals 19. So the first and the fifth term. Now before we get too far into the problem, remember to write the explicit formula of an arithmetic sequence, a sub n minus a sub 1 equals the common difference times n minus 1. So we use point slope form of a linear function just with our subscript notation to write the explicit formula for an arithmetic sequence. In this case, I used the first term, but we can use any term that we've been given. So in this case, we have two terms, but we don't have the common difference, which is equivalent to the slope of the linear function. So I can express both of these terms as a point. So a sub 1 equals 11 would be the point 1 comma 11, right? It's the subscript, the n value, comma, what the actual term is. So here our subscript is 5, so the point would be 5 comma 19, right? N is 5, then a sub 5 is 19. So since we've expressed both terms as points, to find the common difference, we're going to find the slope between those 2 points. So 19 minus 11 over 5 minus 1. So that's 8 over 4, which is equal to 2. So our common difference is 2. And we have 2 points. We can choose either of them to write our explicit formula with. We'll use the first term since that's simpler. So a sub n minus 11 equals 2 times n minus 1. And typically we're asked to solve for a sub n, so a sub n equals 11 plus 2 times n minus 1. So there we have the explicit formula for this particular sequence given just two terms. We could have also written this with the point 519. We just would have had a sub n minus 19 equals 2 times n minus 5. Same directions, the two terms they've given us in this example are a sub 4 equals negative 7 and a sub 10 equals negative 9. So the fourth and the 10th term. So expressing them as points, we would have 4 negative 7 as well as 10 negative 9. So we want to find the common difference of this arithmetic sequence. So we find the slope between the points. So negative 9 minus negative 7 over 10 minus 4. So that's going to be negative 9 plus 7 over 6, which is negative 2 over 6, which we can simplify to be negative 1/3. So our common difference is negative 1/3. Now we have two terms, we can choose either of them. Let's choose 4 negative 7, and we have the common difference, which is our slope. So the explicit formula is, that's not a very good a sub n plus 7 equals negative 1/3 times n minus 4. Solving for a sub n, negative 7 minus 1/3 times n minus 4. Now, oftentimes when you're asked to write the explicit formula, they use the first term, and we clearly don't even know what the first term is. So if it was a multiple choice question, my advice would be to simplify our answer here, and then simplify the answers in the multiple choice. So what we could do is take this negative 1/3 and distribute it in. So a sub n equals negative 7 minus 1/3 n plus 4/3. So that means, let's see, negative 7 can be written as negative 21 over 3. So a sub n is negative 1/3 n minus 17 over 3. Okay, so we could either have stopped here, or we could have simplified to get what looks like slope-intercept form opposed to point-slope form. Both of these are correct explicit formulas for the sequence that we were given. Again, the only reason to go through the simplification, if you come up with this answer, and let's say it's a multiple choice question, and you don't see that as a choice, simplify your answer, simplify the choices, and then pick the correct one. Find the 22nd term of an arithmetic sequence with a first term of -1 and a common difference of 8. Okay, so let's write this out with correct notation. So first term of -1, so that means a sub 1 equals -1. Common difference of 8, so d equals 8. We can write this as a point, so that would be the point 1, -1. And we can create an explicit formula. So a sub n plus 1 equals 8 times n minus 1. So a sub n equals -1 plus 8 times n minus 1. Now they're asking us to find the 22nd term, so n equals 22. So when n equals 22, we'll plug that into our explicit formula, and we get -1 plus 8 times 22 minus 1. So the 22nd term is -1 plus 8 times 21, which is -1 plus 8 times 21, that's 168. So the 22nd term is 167. Now, just a point of note that I made in the previous video, make sure we're doing this multiplication first, right? PEMDAS says multiply before you add. Find the 35th term of 42, 38, 34, 30, 26, continuing on. So here they just gave us the sequence, and we want to find the 35th term. It is arithmetic because there is a common difference. Right? If we look, we're subtracting 4 to go from one term to the next consistently. So the common difference is -4. The first term, a sub 1, is 42. So we can express that as a point, 1 comma 42. So we can write an explicit formula first. So a sub n minus 42 equals -4 times n minus 1. So a sub n equals 42 minus 4 times n minus 1. And then we want to find the 35th term, so that's when n equals 35. We'll plug 35 into our explicit formula. So a sub 35 equals 42 minus 4 times 35 minus 1. So a sub 35 is 42 minus 4 times 34. So a sub 35 is 42 minus 120, 136. So a sub 35 is equal to -94. So the 35th term of this particular arithmetic sequence is -94. Find the 100th term of an arithmetic sequence with a third term of -3 and an 11th term of 45. Okay, so let's express this with our subscript notation. So the third term, a sub 3 equals -3. 11th term, so a sub 11 equals 45. So we have two terms of the sequence. We don't have the common difference, but we can express these terms as points. So 3, -3, and 11, 45. So the slope between these points would be the common difference. So d for the common difference equals 45 minus -3 over 11 minus 3. So this is 45 plus 3 over 8, which is 48 over 8. So the common difference is 6. We can use either term that they've given us. We'll use the third term to write our explicit formula. So a sub n plus 3 equals 6 times n minus 3. Notice n minus 3 now because that's the term that we're given. So a sub n equals -3 plus 6 times n minus 3. Now earlier we simplified this, which we can do But in this case, it doesn't really matter what our explicit formula is as long as it's correct, because we're looking for the 100th term. So we need to plug in n equals 100. So as long as our formula is correct, we just need to plug in. So a sub 100 equals negative 3 plus 6 times 100 minus 3. So a sub 100 equals negative 3 plus 6 times 97. So a sub 100 equals negative 3 plus 500, so let's see, 540, and then 42, 582. So the 100th term is 579. Okay, so could we have simplified as we did in that earlier example when we don't have n minus 1? Of course. But in this case, doesn't matter because we're plugging in n equals 100 anyway. Determine which term of each arithmetic sequence is given. Assume n is greater than or equal to 1 for each sequence. Okay, so they give us the sequence 6, 5, 4, 3, 2, continuing on. And they want to know what term is negative 74. Is it the 70th term? Is it the 110th term? That's what we're trying to figure out. In order to do that, we need to write the explicit formula for the sequence that we were given. So we should note that the common difference is negative 1, right? Subtracting 1 to go from one term to the next. The first term, a sub 1, is 6. So we can express that as the point 1 comma 6. And we can write the explicit formula, a sub n minus 6 equals negative 1 times n minus 1. So a sub n equals 6 minus 1 times n minus 1. Now, because we're going to set it equal to negative 74 at some point, let's clean this up, make our life easier. And we've done that in previous examples anyway. So we can distribute this negative 1. So 6 minus n plus 1. So a sub n equals 7 minus n. The reason for simplification is they told us what a sub n is equal to, right? It's equal to negative 74. Somewhere along the line in this list of values, we're going to get negative 74. So we're going to set our explicit formula equal to negative 74, right? A sub n, a sub n. So negative 74 equals 7 minus n. So we can subtract 7 from both sides. So that's negative 81 equals negative n. And we get 81 equals n. So negative 74 is the 81st term. So hopefully now looking to the right side here, you can see why we simplified. Just made solving easier. Could we have set negative 74 equal to 6 minus 1 times n minus 1? Of course. We just would have had a few extra steps in solving this equation. Same directions. Our sequence now is 7, 11, 15, 19, 23, continuing on. And they want to know what term is the 207, right? Is it the 50th term? Is it the 500th term? That's what we got to figure out. Again, we'll start by writing the explicit formula. So the common difference here, we're adding 4 to go from one term to the next. The first term is 7, so we can write that as the point 1, 7. So the explicit formula is a sub n minus 7 equals 4 times n minus 1. So a sub n equals 7 plus 4 times n minus 1, which we can again simplify. 7 plus 4n minus 4. So a sub n equals 4n plus 3. We want to set that equal to 207. We're looking for the n value, which is the term. So 207 equals 4n plus 3. We can subtract 3 from both sides, so 204 equals 4n. And then we can divide both sides by 4. I'll write that one out. So if we divide by 4, that would be 51 equals n. So 207 is the 51st term of this sequence. Write an explicit formula to find the nth term in the following arithmetic sequence. Assume n is greater than or equal to 1. So first reaction here is, that looks like a really hard sequence. Where's the numbers? Why is there letters in it? And as we discussed earlier, a sequence can be a list of anything, numbers, symbols, shapes. So they just happen to have variables in each term now. Doesn't change our approach. First thing we want to do is identify the common difference. So our first term is 2b minus 1. Next term is 2b plus 2. After that, 2b plus 5. So it looks like 2b is staying consistent and only the constant value is changing. So to go from -1 to 2, I would add 3. And then 2b plus 2, if I add 3, I would get 2b plus 5. Add 3 to that, I would get 2b plus 8. Add 3 to that, I would get 2b plus 11. Okay, so common difference is just plus 3. So that's not too bad. The first term, a sub 1, is 2b minus 1. All right, that's not really simple, but it wasn't hard to write. And we can express this as a point, 1 comma 2b minus 1. So now we approach it the same way. So a sub n minus, in parentheses, 2b minus 1. The reason I need parentheses now is it's not just a single number. And that equals 3 times n minus 1. So I move this term over, so a sub n equals, we'll keep the parentheses, 2b minus 1 plus 3 times n minus 1. Now, looks complex, but we didn't do anything differently. We identified the common difference, we identified the first term, we wrote our explicit formula using that point slope structure, and solve for a sub n. Might look hard, but that's okay. We're not doing anything else with this, we're just writing the formula. Our last example is going to make us think a little bit. Determine the value of x that makes the sequence below arithmetic. Okay, so what do I know about an arithmetic sequence? I know that it has a common difference. And that is going to be key in solving this problem. So this sequence only has 3 terms. First thing, let's determine how to get from one term to the next. So to get from x plus 2 to 4x plus 5, we're going to add 3x plus 3. And then to get from 4x plus 5 to 10x minus 1, we're going to add 6x minus 6. Now, most students' reaction to seeing this is, then this can't be arithmetic. Those are 2 different things. And I would agree with you. But we're looking for the value of x that makes these 2 different things the same. Because that's what's going to make these the common difference. Is there a value of x that if we plug in, these 2 expressions will be identical, and it's really like we're adding the same amount to get from one term to the next. Okay, so this is the key in the problem, understanding why we're setting these 2 things equal. Again, because it is an arithmetic sequence, it has a common difference. What we add to go from one term to the next should always be the same. So even though they look different, we know they're really the same based on whatever value of x we find. So let's solve this. So we can subtract 3x, so 3 equals 3x minus 6. Add 6 to both sides, 9 equals 3x. Divide both sides by 3, 3 equals x. So if x equals 3, that makes this sequence arithmetic. Well, first, does it make the common difference the same? So 3 times 3 is 9, plus 3 is 12. 6 times 3 is 18, minus 6 is also 12. So these numbers would be the same. And even though they don't tell us to find the sequence, let's write it out to really understand it. This sequence, if we write it out, x plus 2. So that first term would be 5. The next term, 4 times 3, 12, plus 5 is 17. And then 10 times 3 is 30, minus 1 is 29. Now, is that an arithmetic sequence? Well, if I add 12, I get to 17. If I add 12, I get to 29. So it works. If x equals 3, this is an arithmetic sequence. So it seemed like a hard problem at first, but if we understand the concept of an arithmetic sequence, that idea of a common difference, this problem works out nicely. So that wraps up arithmetic sequences. We looked at them both recursively and explicitly, right? We connected an arithmetic sequence to a linear function. All the key ideas came together. So now practice with the arithmetic sequences and make sure you're confident with them before moving into the next video, where we start to learn about geometric sequences. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.